So primarily, I want to talk about storage solutions that are going into NFPA 13. And in the 2016 edition of NFPA 13 that exists right now, it's out there, it's available to us, it has some new protection criteria for exposed plastics. So if we go back to the 2013 edition of NFPA 13, we have a warehouse that looks a little something like the one on the screen here, and we say, well, do we know how to protect this based on NFPA 13? And the answer is yes. And how do we know that? Because the checkbox is checked, and that's how we know it. But on top of it, we know that 13 tells us how to protect carton commodities. If we go back to the 2013 edition of NFPA 13, and we try to use that to protect a warehouse that looks a little something like this image on the screen, that's exposed expanded plastic commodity, what we find out is it doesn't tell us how to do that. And we know that because it's not checked and the words are crossed out. But also, if you go into the flow chart in the storage chapter of NFPA 13, 2013 edition, you work your way through it to exposed expanded plastics, and you get down there and it says outside the scope of this chapter. Sort of true. It's outside the scope of that chapter. It's also outside the scope of the entire book. Then we get to the 2016 edition. All of a sudden, we have two new criteria for something that could never be protected before with an NFPA 13 criteria. We have one involving K25 VSFR sprinklers and vertical barriers. Carrie Bell is going to talk a lot about the research and the work that went into developing that criteria. There's also a protection scheme using K8 or larger in-rack sprinklers with horizontal barriers. And that we'll talk about a little bit here. I'm also going to talk about one protection scheme that's proposed into the 2019 edition of NFPA 13 that so far is making its way through the committee just fine. And I'll also note that Chris talked about the ESFR in-rack work that Factory Mutual has done that also would then be a fourth option if everything goes along how it seems like it's going in the 2019 edition of NFPA 13. So let's talk about the K25 VSFRs at the ceiling with vertical barriers. There's a group separate from NFPA, although located in the same building, called the Fire Protection Research Foundation. When an NFPA technical committee or an end user or someone in the industry has a research project, they need some criteria developed, they need some research done, the Fire Protection Research Foundation, if they have funding, will put together a project and look into an issue. And they do surveys of their advisory boards on what do they need to look into. And back at the time, back when the 2013 edition was out, their number one priority in storage was protecting exposed expanded Group A plastics. So Carrie's going to talk all about the research that was done for this. The thing to keep in mind from this is that we look at a list of sponsors that's end users, sprinkler manufacturers, insurance companies. And it's really nice when the industry can bring different interests together and fund it through several different funding sources to achieve something that's really a $1 million+ project, but that's done in a way that provides great criteria into 13 at the end. The other nice part about it is all of their research is available on the Fire Protection Research Foundation's website. So you can go to the Research Foundation website and look up all their reports on any of the work that they do. Their approach, and Carrie's going to talk a little bit more about this, was to use vertical barriers in the racks and 8-foot aisles to separate out the area involved in the fire from other spaces, help out the sprinklers. We knew already from FM's data sheets that if we tried to do this work without the vertical barriers, without the wider aisles, we knew that we would have a very substantial water demand. And so part of the goal of this project was to come up with criteria that didn't reinvent what FM had already done. It was take another approach at it, see if we can come up with protection criteria using less water. And to do that, we want to slow the fire spread down, put some vertical barriers in the rack, and then make sure the aisles were wide enough that the fire didn't go from one side to another. Carrie talked about all the test piece of it, and we'll just go right through that. I'm going to discuss the criteria that resulted from it. So when we get into NFPA 13, we end up with a criteria that applies to single, double, and multiple row racks. 12-foot ceilings maximum with about 12-meter ceilings with 11-meter storage and 2.4-meter aisles to protect exposed expanded plastics. The sprinklers that were tested were K25 intermediate temperature ESFR sprinklers. And they were used only at the ceiling. The end users that were involved said for a 40-foot, for a 12-meter building, we don't want to put in racks in. We want to try to do this at the ceiling, even if it means using a fairly substantial ceiling sprinkler system. So the criteria for a 12-meter ceiling is 12 sprinklers calculated hydraulically at 4.1 bar, 60 psi. So that's got a water demand of about 9,000 liters per minute, something right around there. Fairly substantial, but manageable. There was also an additional test series conducted by the Research Foundation to look at 30-foot or 9-meter ceilings to come up with a criteria that's a little bit less there. And so that one came up with a 2.1 bar criteria, so about 6,400 liters per minute. One thing I'll point out about that is if you look in FM's data sheets, they have a criteria that's really very similar once you get down to 30 feet, but doesn't require the vertical barriers or the 8-foot aisles. So you still might think about using the FM criteria for something like this. The next protection criteria that went into 13 and NFPA 13 in 2016 used horizontal barriers with in-rack sprinklers that were K8 or larger. And if you look at this and look at the requirements in 13, you'll see that it's very similar to FM datasheet 8-9 scheme 8-9A. It's very similar to that. It's also real similar to a section in NFPA 13 on solid shelves, and it's very similar to some NFPA 30 criteria for combustible liquids. Some prior tests on that. So the last criteria I talked about, ceiling only K25, Carrie is going to tell you for 20 minutes about all the fire testing that was done on that. Fire test after fire test. This criteria, in racks, horizontal barriers, how many fire tests were submitted for this one? Carrie? 0. None. The code change was put through based on similar systems that were already in the code and the committee's comfort that, quite frankly, if you put in that many in-rack sprinklers, it's probably going to work. So that one uses horizontal barriers to cover over a rack level, permits some gaps at the upright. Those barriers have to be 3.7 meters maximum apart. So they're fairly close. And under each of those barriers, we have a level of in-rack sprinklers. I'll show you where those are in a few minutes, but hydraulically, the system's actually pretty good. Like the system that Chris talked about earlier, this one's not balanced with the ceiling sprinkler system. So if you go in to do a retrofit, you do something else, it's probably not going to be a big deal in terms of water demand. Your ceiling system is probably still more. For a double or multiple row rack, you're going to calculate 8 sprinklers, 230 liters per minute. So it's really, in terms of water demand, not all that bad, primarily because you don't have to balance the in-racks with the ceiling system. You calculate them separately. The in-rack sprinklers, K8 or larger, quick response sprinklers. A lot of times you might use a K11 for that, just to get your pressure down a little bit, but that's the type of sprinkler that's used there. For a single row rack, you end up with sprinklers in the rack between every single set of commodities for a standard commodity. For double row racks, at the faces, sprinklers between every single set of commodities and then every other in longitudinal flue. Multiple row racks does a repeating pattern. Full lines with sprinklers between every pallet load, alternating with lines between every other pallet load. So what's the key to this? It's good protection. It protects all kinds of commodities. The water demand is very reasonable. The downside from an installer standpoint and end user standpoint is that's a lot of sprinklers. It's this number of sprinklers at every 2.4 meters apart. That's a lot of sprinklers in a tall building. So FM went down a road with ESFR sprinklers to do something, to essentially take something like this and spread the sprinklers apart more vertically. So you end up with, what they've looked at and their data sheets show, something that might go 9 or 12 meters apart between in-rack levels. Pretty substantial. What we had done is look at, well, can we move the sprinklers apart more horizontally? But to do that, we're not going to use a standard coverage sprinkler. We're not going to use a sprinkler that covers 3 meters by 3 meters. We're not going to use an ESFR. It pushes down. We need extended coverage. So this is proposed in the 2019 edition of NFPA 13. So far, committee said OK to it. We'll see what happens. There's a couple more rounds to go. Russ talked about that yesterday. We're at the initial public input phase right now, getting through that in the first meeting. So there's still comment phases and so on moving along here. The intent is to take a system like the one you saw before that's already in NFPA 13 and 2016 edition and eliminate about 1 out of every 5 in-rack sprinklers on each level. So for a double row rack, you get rid of the face sprinklers, put the in-rack sprinklers only in the longitudinal flue, and only at essentially every other transverse flue space. You spread them apart. Multiple row rack, has been some testing done out to about a 4 pallet deep multiple row rack. And that one also spaces out the sprinklers farther, puts some little bit inboard of each face, again, every other, and then staggered with sprinklers in the center flue, also at every other transverse flue space. Eliminates an awful lot of sprinklers from the job. You eliminate essentially 1 out of every 5 on each in-rack level. And on top of that, the in-rack levels get spread apart from about 3 meters up to about 6 meters for expanded uncartoned commodity, and even farther apart, 9 meters for cartoned commodity. How's this happen? Well, in-rack sprinklers, we've seen an awful lot of development over the past 30 years in storage sprinklers at the ceiling. But until the last few years, in-rack sprinklers, not a lot of development. No one really wanted them. All of a sudden, buildings get higher. And Chris mentioned it earlier, we keep seeing taller and taller storage. And now, as of today, you need in-rack sprinklers in those buildings. There's not an alternative. So we saw the opportunity to do some development on in-rack sprinklers and take some of the technology that we looked at the ceiling that's really largely replaced some of the smaller K11, K8 sprinklers at the ceiling and use that in a rack. It's been tests run with a variety of commodities, exposed plastics, carton plastics, combustible liquids, even lithium metal batteries. Now it's time for some fire test videos. So this is one of the tests. This is actually the first test. So when the testing that Carrie is going to talk about in a few minutes here was going on, Reliable came in and said, well, why don't we try something similar, but instead of trying to put a lot of water at the ceiling and all the vertical barriers, let's see what we can do about putting 1 level of in-rack sprinklers in, 6 meters above the floor, in a 12-meter tall space, and see if that 1 level of in-rack sprinklers, along with the ceiling system, can deal with an exposed, expanded plastic commodity. And that commodity, Carrie's going to show you an awful lot of tests with that, but if we're looking at the screen here, it's a little hard to tell what that is, the white commodity on that rack. It's actually, so it's polystyrene meat trays. So it's trays, several 100,000 of them, stacked up on pallets of polystyrene. So they burn real quick, put off a lot of radiation, very hard fire to deal with. It's a little shot showing the horizontal barriers and the in-rack sprinklers. Again, only in the longitudinal flue, only 1 per bay, only 1 per rack bay. Another shot looking down the line. So at the ceiling, we had typical ceiling system for a 12-meter tall building, K17 ESFRs. In the rack, we had the K25 EC pendant at 2 bar. So this is not the best video quality in the world here, but there's going to be plenty of fire, so you're not going to miss it. This is, again, 12-meter tall building, exposed expanded plastic, something that could not be protected in the 2013 edition NFPA 13. One level of in-rack sprinklers, only in the longitudinal flue. Fire started out on the face, 2 igniters. These tests, and we ran a lot of them with the foundation, these tests all look about the same. Flame spreads up the rack, takes 45 seconds to get up to the ceiling or so. This one's going to be stopped a little bit by that horizontal barrier. You'll notice it when the sprinkler operates in the rack because that fire gets knocked down. So it hit the barrier right there, and in just a second here you'll see the sprinkler operate and you'll see the fire come back down to the floor. Got a little smoke, a little white steam, and a little push downwards there. And next thing you know, we go from a fire that's heading up towards the ceiling very quickly down to a fire that's well controlled in the bottom couple of levels. This seems like still a decent sized fire, but the reality is when you see some of the videos that Gary's going to show you with what this happens with just ceiling sprinklers, this is really incredibly good performance. So we may as well move on to the next video here. So this is a test with carton commodity. We move the barrier from 6 meters up to 9 meters. Same exact sprinkler layout. And the commodity in this one is cartoned unexpanded plastics. So it's plastic cups, hard plastic cups, polystyrene, but hard plastic cups, stacked inside cardboard boxes. This one's ignited inside the transverse flue. You've got a shot in the top left corner that shows a camera up near that barrier level, where at some point here, when that fire spreads up the rack, you're going to see a little bit of flames coming up in that top left corner. There it is. Some little embers that get pushed up to the rack, up to that 12-meter level where the in-racks are. After they're up there for just a few seconds, sprinklers operate, and you'll see what happens. There we go. So this is something that we see as having great application for taller buildings, either doing levels at multiple in-rack levels at 12 meters apart, or let's say we had a building that was 18 meters, something like that. Do one level of in-rack sprinklers and then protect what's above that barrier based on the sprinkler system design as if that barrier was a floor. And so you can really do, at that point, once you get to something around 9 meters or so, you can do EC sprinklers. All of a sudden, the cost of your ceiling system, the water demand goes way down, provide the in-racks to get the height, and you have a water demand that's really very minimal to protect buildings that are very tall. We think that's important in a lot of places. This is where we see storage going. I think we all agree on this. I think everybody's going to have something that talks about these buildings going taller and taller. There's going to be some different options on how you protect these, but these are just a few of them. You can look in NFPA 13 for 2016, and then we think you're going to have at least a couple of more come up by the 2019 edition. Thank you very much.